All right, so we got the screen up, everything looking good?
Yep, we got it. It looks good.
Excellent. All right, well, thank you everybody for joining. As Amy mentioned, this is our webcast on the Linux virtual machines for Windows Azure. A little bit about me. I am Michael Collier. I'm the Windows Azure National Architect for Neudesic and also a Windows Azure MVP. If you want to get a hold of me, all my contact information is up here on the screen. My role in Neudesic is kind of unique, and I get to help our customers all across the country with their Windows Azure projects. This can include architectural design sessions, cloud assessments, architect or developer training, assistance with development efforts, evangelism, anything really related to Windows Azure. Again, if you want to talk about Windows Azure or anything, all my contact information is there. Hit me on email, Twitter, or check out my blog at michaelscollier.com. This is the fourth in a five-part series on meeting the new Windows Azure. So far, we've covered the new HTML-based portal, Windows Azure websites, Windows virtual machines. Today, we're going to be covering Linux virtual machines. And then next month, on November 13th, we'll be covering cloud services. You can go ahead and register for these webcasts on our page at neudesic.com. Go to About, and then Events and Live Webcasts. You'll be able to sign up there. All right, so let's go ahead and jump into this. With Windows Azure, there are really three kind of key areas to choose from. We have Windows Azure websites, which give us a managed, fast, simple, and free way to start building web solutions. This is really ideal for web applications or services. We have cloud services, which we're talking about next month. These are robust, scalable, potentially multi-tier platforms to build an application. It's really ideal for scalable web or back-end services. And then we have virtual machines, which we're going to be talking about somewhat today. And these are machines that you can do pretty much whatever you want with. They're ideal for anything where you need to host an environment or need an environment in which you want to host your solution. That's what we're going to talk about today is the virtual machines, specifically the virtual machines where you can run Linux distributions on them. So before we get into too much depth on the virtual machines, I really want to cover a little bit on platform as a service, just to kind of set the stage on how platform as a service and infrastructure service are a little bit different from each other. So we talk about platform as a service. It's a managed solution. And that, when we say managed, that really means that operating system updates and optionally patches are really handled for you. If there's a machine or hardware failure, that can automatically be recovered, meaning that your application is moved to new hardware within that data center. You design a solution for that platform. So that means that applications are designed to run as stateless instances. They're really designed to be resilient in the face of failure. We know that a failure can and will happen, and we want to be prepared for that. And a failure is because of hardware failure. These are commodity servers. Failures happen all the time, but this type of hardware is just a fact of life. If we know it's coming, we can make sure that we design solutions to be able to handle that. And then apps are designed to run as multiple instances. It's really not a focus on the individual machine so much with platform as a service, but as a focus on the service itself, and we have multiple machines that are handling and powering that service. And with platform as a service, we want to take advantage of those platform level services, those kind of value adds to that we get with that platform, things like storage services, identity management services, global traffic management, APIs related to our configuration and our environment as well. So we look at the platform as a service model. We see we have a couple of things we want to talk about. You'll kind of see some relationship between what the platform as a service has here a little bit and infrastructure as a service as well. We have a role. A role is basically like a template for a machine. You can think of it as a model. It defines the logical shape of our solution. And within that role, we have instances. An instance is really an instantiation of that role. It is, for all intents and purposes, it is a virtual machine that's been customized a little bit to work in this particular model, and we'll kind of see some differences between these virtual machines and the infrastructure as a service virtual machines we'll be talking about today. And that role can contain multiple instances. So then we go ahead and add a load-balanced, publicly available endpoint. So as requests come into that load balancer, they're distributed in a round-robin fashion to those instances of our virtual machines. And then in this model, we can take advantage of other services like Windows Azure SQL Database, Windows Azure storage services like tables, blobs, and queues. And it's important to note here that these particular virtual machines we're talking about in a Paas model are non-persistent VMs, meaning anything we write to the local disk, like our C drive or our user folders, on that virtual machine. These are non-persistent, so that if there is a failure of that machine, anything will be right there is not going to be persisted when that machine is brought up, or that instance is brought up on new hardware. If we want that sort of persistence, we have to go to a persistence store like SQL database or Windows Azure tables or blobs. And inside this model here, we have the idea of fault domains. And we'll see fault domains as they kind of apply to the infrastructure as a service as well. But basically, a fault domain in Windows Azure is defined by basically a single point of failure, like a network switch or a power unit on a rack of servers. In fact, a fault domain is actually closely equivalent to a rack of physical servers. We kind of see that here in the diagram. If we lose an entire fault domain, like let's say we lost fault domain 2, we wouldn't lose our entire service. We'd have fewer servers temporarily available because we've lost, in this case, 3 of our servers. But our service would still be online. Windows Azure would automatically spin up a new service to replace the one that we lost and keep us going. So the cloud services are really ideal for those scalable solutions. And when I say scalable, it's scaling in and out. We want to be able to extend to tens, hundreds, or thousands of virtual machines by changing that configuration setting, or be able to scale that back in as well. And we can do this all without having any sort of local presence. So no physical presence is required. We can deploy these solutions all across the world. This could be websites or web services that are running there, and even background workers. Background workers are really similar in a lot of ways to a traditional, service, cron job, Windows service, whatever you have there. There's really no user interface for these. I see a lot of people running these kind of like compute-intensive solutions where I just want to kind of crunch on some numbers or a file or a video or something like that. So with best platform as a service, we kind of compare that to infrastructure as a service, where it's something that you manage. You have total control over that machine. You're responsible for any sort of patches or updates or configuration on that machine. One of the really nice things about Windows Azure virtual machines is a high degree of portability that the platform offers. Windows Azure virtual machines, whether they're Linux machines or Windows Server-based machines, they all run on the VHD format, just a virtual hard disk format. The nice thing about that VHD format is we can move that from our on-premise infrastructure as well to the cloud with Windows Azure. So we can easily move between on-premises and the cloud, giving us a great deal of flexibility and portability in how and where we want to run our solution. And the nice thing about this is that with infrastructure as a service, it's really that least common denominator. We're running basically, you have the operating system, you have the machine, and you can put what you want on it. So it gives us there's really no other platform level services or APIs you really have to worry about. This is just the machine, do with it as you see fit. So we look at the infrastructure as a service model here. We see that we have multiple virtual machines, so somewhat, similar construct to what we saw with platform as a service. We have these virtual machines, and then we're going to add a publicly available load balanced endpoint as well, so that requests coming in are routed to the appropriate machine. And the machines can be Windows Server-based machines or Linux machines. And the VMs are actually persistent here. So we saw with the platform as a service model where those machines, anything we write locally is not persistent. But with the infrastructure as a service model, these VMs are persistent down to Windows Azure blob storage. We'll be talking a little bit more about that coming up here as well. And you'll notice there on the left-hand side, we have an availability set. An availability set is a feature of Windows Azure virtual machines, and it's somewhat similar in concept to what we talked about with a fault domain. In fact, when multiple virtual machines are connected together, an availability set can be used to ensure that those machines are located in different fault domains. With an availability set, virtual machines are located in different fault domains and update domains. So it gives us that nice degree of ensuring that we don't have any sort of downtime within our solution. So virtual machines, they're really ideal for those cases where we want to forklift that existing application to the cloud. I want to move this existing solution to the cloud without having to really change any of my application code. It's great for cases where I need to have that persistent storage of my operating system data, where my system configuration changes are preserved in Windows Azure storage, giving us that high degree, that high availability that we often desire. It's great for single server solutions where those changes and customizations, whether it's operating system or software that we have, as server solutions we have, that's applied just to that one instance of that virtual machine. And we have that full control then, where I can remotely access that virtual machine, whether it's remote desktop with Windows or something like SSH or Putty in a Linux system, I can then perform that maintenance and troubleshooting task to doing what I need to do with that machine. So if you want to compare these, I'm not going to read these all out for you. You can kind of look through most of them here. I want to point out a couple of things. One, cloud service is a platform as a service model that is released and generally available today, whereas the virtual machines, the things that we're talking about today, they are in a preview mode. And because they are in a preview mode, they have a different level of availability right now, or an SLA. Platform as a service is 3.5 nines. When virtual machines are released, they'll have a minimum of 3.9 or 99.9%, but there is no SLA today because they're not still generally available. Persistence is probably the single biggest difference in how people use the two different models of handling their different services, whether it's platform or infrastructure as a service. Like I said, platform as a service, there's no VM persistence. You have to use something like Windows Azure storage or a database to persist that data across instances. Whereas with a VM, you're writing basically what amounts to disk, and we'll see more about the disk coming up, writing that disk, and it is persisted in that way. The other probably big difference between the two models is the kind of configuration and deployment model. With the cloud service, you have a service definition, service configuration files that you have, and you package them up into a service configuration package and deploy that package up into Windows Azure. With the virtual machines, we don't really have any of that. It's basically you're having a VHD file, and whether you're provisioning that from the cloud or building that on premises and uploading that to Windows Azure, that's really all you have there. It's just that virtual machine, just that VHD file that you're using, and you can configure that however you want to do that. So we look at the different sizes and pricing options that are available. The size of the machines are similar, or actually the same across, whether it's a Windows server-based machine or a Linux machine. You get the same sizes. There's the pricing that really is the difference between those two. So we see that with an extra small, we start with a shared core, 768 megs of memory, 20 gigs of local storage, and that giving us a discounted rate right now, a preview mode of 33% discount. And so it's about 0.013 cents an hour for that when virtual machines are generally available, hopefully sometime soon. Well, those will be available at 2 cents an hour. And you can kind of see as we go up in size, it costs us a little bit more as well, but there's a little bit of a discount available to help out. So we talked about the disk. I think that's an important thing to spend a little bit of time talking about. And when we talk about Windows Azure virtual machines, there's two kind of key pieces we want to talk about. It's the images and the disk. An image is the it's essentially that OS image for creating a new virtual machine. These images can be created by Microsoft for the Windows Server platform, by partners, as we'll see coming up here, for the Linux machines. There's several different partners that are providing those Linux distros available to run in Windows Azure, or they can be images that you provide yourself. Maybe you have a Linux image that you've configured. You've gone ahead and captured that image. We'll see that coming up, capturing that image and uploading that into Windows Azure. So that way I can use that image as a template for creating new VMs going on. So if I want to scale out, I pull that template in and instantiate that image. Then we have disk. We have two different types of disks. We have OS disk and data disk. And these are writable disk for your virtual machine. So obviously an OS disk is that operating system where the operating system is installed, put on there, and where the OS itself writes all of its information. Then we have data disk. By default, you don't have a data disk attached to the machine you're running. You can optionally add in multiple different size data disk up to 16 1 terabyte data disk, 16 being the maximum number for an extra large, and it basically goes down from there. We have these data disks that we can attach, again, maximum of a terabyte in size, be mounted into our machine so that we can install, if we want to use those data disks to install and store different source of data for our applications, that's where we can do that. And these are just VHDs as well. So I think it's important here to talk a little bit about the persistent mechanism that we have with Windows Azure virtual machines. So in this case here on the right, we see a picture of some disk in Windows Azure storage. And it's important to note that when we have these disks in Windows Azure storage, they're actually persisted in triplicate. So if I'm writing to disk, I actually have 3 copies of that disk in Windows Azure storage. This is not for you kind of what I call oops recovery, where if you made a mistake, you go back in and kind of roll back to previous version. these disks are made for the high availability and redundancy of the system. So if we do get to a case where there is some sort of failure and a hard drive fails, that's okay because Windows Azure will spin back up another instance for us. We know that we have these 3 copies at all times available to ensure a high availability of our storage of our machines. The nice thing about these is it gives us that guarantee, that comfort feeling we want that these machines are going to be reliable and always on. Well, the nice thing here is we also have the idea of a geo-replication service that's enabled by default. So while we're triple replicating within a single Windows Azure data center, we're also geo-replicating that data to a secondary data center. So if we take the example of the East and West US data centers, take that where maybe our West is our primary data center, and we're writing triple replicated data there. And let's say there's a problem with that West data center. Something, some disaster happens and that data center goes offline and it's declared unrecoverable. Automatically, that data has been asynchronously replicated across the Eastern US data center. Microsoft makes a DNS switch, and we're back up on the Eastern US data center automatically. This is a nice feature that's available. It's enabled by default. If you don't want this feature, you can certainly disable that. You can go into the Windows Azure portal and turn that off and get a little bit of a cost savings in that respect. So when it comes to virtual machines, how do we get started? We mentioned that virtual machines are in a preview mode, and one of the things you're going to need to do is go out to account.windowsazure.com and log in with your Windows Live ID and go to the preview feature. So you can click on the preview features link or just go into the URL we have here on the screen. That's going to show you all the different features of Windows Azure that are available in kind of a preview mode right now. Preview is essentially replace the term for beta. They're trying these out, giving you some feedback, whether you like, whether you don't like. With the services, we have things like media services, Windows Azure mobile services, Windows Azure virtual machines and virtual networks is what we're going to be working with today. So I would go ahead and click on the green Try It Now button there. And that'll may take a couple seconds to minutes, hopefully not much longer on that, to provision your account with support for Windows Azure virtual machines. So we talked about the different flavors of Linux distributions that are available. There are 4 Linux distributions officially supported for Windows Azure virtual machines. And Microsoft has dedicated support engineers available to help with these distributions. And they're provided by Microsoft's partners. And we have 4 of them right now. We have Ubuntu available, CentOS provided by OpenLogic, and 2 OpenSUSE variants as well, one enterprise server and another one as well. So what I want to do now is take you into the Windows Azure Management Portal and really just kind of show how easy it is to go ahead and get started creating a new Linux virtual machine. So for in here, I'm going to go over to my web browser. And I've logged into, let me minimize this little bar up here. So I'm into manage.windowsazure.com already, logged in with my Windows Live ID, and I have virtual machines already provisioned in my account. What I'm going to do here is I'm going to click on the new icon. I'm going to do virtual show compute, a virtual machine, and I'm going to say from gallery. Now on the gallery tab here, I can see all the different images available to select from. I'm going to just say platform images here and filter out some of those. So you can see here I have the Windows Server variants available as well as several different Linux distributions. I'm going to go ahead and click on the OpenSUSE 12.1. To click the little area here, do next. And I need to give it a virtual machine name. This is just naming this virtual machine that I'm creating. So I'm going to call it MC Web. Let's call it Web-1. I need to give it a username. This is my administrative account on the server. So I'll call it mcollier. Give it a password. And I typed something wrong here. Let's go back in and try that again. Confirm that password. And then I can pick out what size of virtual machine I would like. So I want an extra large, large, medium, small, or extra small. I'm going to go ahead and click small for this one. And if I want, since it's a Linux option, I have 2 different ways on how I can authenticate. I can use, if I have an SSH key already, I can go ahead and upload that key. I don't have one of those ready for this one. I'm going to use Putty to go ahead and log in. So you can choose how you want to authenticate and access the server. I want to go ahead and click Next here. And then I can choose how I want this machine to be configured. I want it to be a standalone virtual machine, or I want it to be part of an existing virtual machine. What the second option is here, connect to an existing virtual machine. If I click that, it's going to give me the option to join it to other virtual machines that I have available. So maybe there's a couple of these machines out here I want to put in kind of a load balance set. I can certainly do that. So I'm going to say, no, I don't want to create an existing one. I'm going to go ahead and create this as a standalone. And now I'm going to create the DNS name for this service. Let's just call it MC Web. Make sure that's available. And it is. I can choose a storage account. I need to pick a storage account because I need to say where I want my VHD files to be stored. So I can have the system automatically create me a storage account, or if I have some already available, I can go ahead and pick from those. I want to say, go ahead and create a storage account for me automatically. I want it to be in the Eastern US data center, and I can pick which one I want it to be there. And then I pick out which subscription I want it to be in. So I'm going to say I'm going to use the current Neudesic training subscription here. Go ahead and click Next. Now there's a couple of things on this screen to point out. One is the availability set. We talked about availability sets earlier and how they kind of make sure that our own machines stay up. We don't have any kind of we don't lose all of our services if there's some sort of hardware failure or update of the system happening. So I'll say, yeah, go ahead and I want to create an availability set. And let's call it MC Web Demo. And then I have the option down here, the agreement that kind of legal terms that yes, I am getting the software from a third party, and Microsoft's not providing any rights for that software. So basically, the license agreement for using this. Go ahead and click Complete, the little checkbox here. That'll take a few minutes to provision that server. We can see that MC Web 1 is starting to provision right now. So while that's going on, let's go ahead and look at another one I've already set up so we don't have to wait for that. So I have this other one here, MC Suze-1. If I go ahead and click on that, I see some information about the server. So right now it's going ahead trying to pull in some network utilization. So we can see here in the last hour, got a little bit of usage on this server. If I want, I can change it to something like 7 days, pulling in some metrics. Then at that point, I click on a button. They're pulling in some metrics for the last 7 days on this server as well. So we'll see that come up. We can see information here about our DNS name, what our public IP address is. Also in here, we'll notice this one here, SSH details. We can see that this is how we're going to connect to this machine via SSH. We can see the disk we have, our subscription ID, all that information there. So one of the things we noticed that we talked about as well is disk and how you can attach different disks. We can see we have a disk here right now. It's an OS disk. We can see where this disk is stored. This is an automatically created disk. We see it portal VHD, some letters and numbers there. So it's stored in blob storage. What I could do is if I wanted to attach a new disk, I could say attach empty disk. I could say, okay, that's where the machine I'm going to attach it to. This is the storage location. This is the name of that file. And then I could give it a disk name here. Let's say I want to attach a 10 gigabyte disk. I would say, okay. It's going to go ahead and attaching this empty disk to the machine. And then I would need to go in and actually use the appropriate tools within this server to go in and provision and finish kind of formatting and getting this disk all ready to go. At that point, you just really have an empty VHD file, and there's a great series of tutorials on Windows Azure's website when we talk about that for Linux and how you actually, what tools and things you need to go in and install and finish getting this disk all ready. So we see here the SSH details. What we want to do is go ahead and log into this machine. So I'm going to go ahead and open up Putty. And I've already got this one loaded. So I say, here's my host name, mc-suze.cloudapp.net, running on port 22 using SSH, and that matches up with what we have here on the screen as well. I say, open that. This is going to open a connection here. So I'm going to go ahead and log in with the credentials I already had created. So I'll say mcollier. And then I need to type in my password. And I'm already ahead and logged in. If I run some commands, I can see any sort of information I want on this machine. I can configure it, install any packages using my appropriate package manager. Whatever I want to do this machine, then I have this terminal connection right into that machine. So I'm going to go ahead and say log out right now. Let's see if our machine that we created earlier is done yet. Looks like it's getting closer. Attaching an empty disk to it and having a little trouble refreshing the metrics on this portal. Let's see if we go ahead and refresh the browser here. Sometimes I've noticed that with the preview portal, it doesn't pull in the information continually. Sometimes it'll kind of like, seems like it times out sometimes. So often I just go in and hit the refresh button. I think it should be done, and normally that'll kind of fix the display problem with the preview portal right now. So let's click in here, see if we get any information. So it's like still retrieving the status of that. So that should hopefully be coming up pretty soon as well. We click on Open our MC Tuesday 1. And we see here we have our new data disk that we just created. That's available in Windows Azure Blob Storage now as well. Just kind of, if we wanted to see that, we could go into our storage account and go ahead and browse right to that and look at that file that we have. So I was creating a new virtual machine. So my sharing frame got a little messed up. We'll try to restart that. There we go. So we've gone ahead and created our virtual machine. Maybe we've gone ahead and installed all the software we need to do and got it all ready to go. We want to actually save that virtual machine now down to our image gallery. So what we're going to do is essentially going to snapshot this VM. So you've got it already ready to go. We're going to connect to that VM like we did with Putty. And then we're going to invoke the Windows Azure Linux agent. And the agent is already installed on machines provided from the image gallery. So if I was going to provide my own Linux distribution or my own Linux machine, go ahead and upload that to Windows Azure, I would need to install this Windows Azure Linux agent. So I've got the agent installed already. I would basically just do what you see here on the screen. I would invoke that by saying WA agent-d provision, and that'll kind of remove any of the customizations as far as like server name, that type of sort of stuff from that machine, and get that ready to go. And then I'm going to go ahead and shut down that virtual machine with the shutdown command in the portal on our app bar there. We have a little shutdown button. We would hit that, shut that machine down. Once it's go ahead and stopped, we'll see it say stopped in the portal. Then we can go in and click the capture button. So machine is then, we've run the agent to deprovision it. We've shut it down. We're going to click the capture button, and that's going to allow us to click the create image. Now we can then name the image however we want. We'll click the I have run the deprovision command on the virtual machine checkbox and saying, yep, we're ready to go. And then when we've done that, our image will be available in the gallery for us to go ahead and use later on. So like we could pick one of the images from one of Microsoft's partners. I could start with that image, configure it however I want, install the software, get it ready to go. And now this image is available in the portal for me to use later on. So I could then instantiate an image from my image on this template, so to speak, and then I could use that to scale out or do whatever I want with later on. So how do you manage these machines? There's a great series here on command line tools. One of the nice things about these particular command line tools is they're cross-platform tools. So I can have one set of tools that I can use from any environment, whether it's a Windows machine, a Mac, or multiple different Linux systems as well. If you're using a Mac, go ahead and download the Windows Azure SDK that's available. You just go out to windowsazure.com and go to the manage section. You'll be able to download the SDKs, all the instructions for that. If I'm using Linux or Windows, I want to install Node.js via my favorite package manager. That will vary, it's Yum or whatever, depending on what flavor of Linux you have. And then I just run Node Package Manager install Azure. You go ahead and get that installed. Nice thing about these platform tools is they are built on Node.js, so they do run on multiple different platforms. And with the command line tools, I can really run and manage lots of different things within Windows Azure, whether it's my virtual machines, cloud services. I can upload and manage my certificates. We need certificates a lot of times to handle remote access of our servers. Some X509 certs, we can handle that. Windows Azure websites, very, very easy to work with there. If you want to kind of dive more into this and see some really great tutorials and references on the information on the command line tools, go to windowsazure.com, click on Manage, and then Linux, and then there'll be some how-to guides there, and you can see the how-to guide on the command line tools. Very, very easy to go ahead and get started with this type of stuff. There are some nice additional kind of partner solutions that Microsoft's partner community is building to help support these infrastructures as service machines, whether they're Windows-based machines or Linux machines. Companies like OpsCode, RightScale, Scale Extreme provide some nice solutions. These partners really have done a nice job in getting started with Amazon and their EC2 platform. They also now work very well with Windows Azure and infrastructure as a service as well. So if you're familiar with those set of tools and like what they provide, feel free to go ahead and use those on Windows Azure as well. I want to point out a quick thing here on virtual machine availability. A lot of people get really excited about these virtual machines, and they're a fantastic tool. But it is important to note that there is no SLA while they are in preview. When you coming out of preview, hopefully sometime soon, you'll see a 3.5/9 for multiple role instances. So if I have 2 or 3 of these virtual machines running an availability set, I'll have a 3.5/9 SLA. If I'm only running a single instance virtual machine, then I have a 3.9 SLA for those. And Microsoft has announced that they will be providing at GA, a general availability for these virtual machines, a notification window. So if you only have a single instance, they'll provide you a window that says, hey, we're going to take down this machine during this time in order to do platform level maintenance on the underlying Windows Azure platform, at least giving you an advance notice that, hey, something's going on. Maybe you want to scale out for a short period of time, or plan accordingly for that. So one of the things that comes up a lot when we talk to people about virtual machines is what is a cloud service? It's kind of an overloaded term, just like service is an overloaded term in our industry as well. When we talk about platform as a service, we're talking about creating a cloud service, and we have web roles and worker roles there, and we have multiple instances of those web and worker roles. And also we're talking more about these type of features next month in our webcast. With infrastructure as a service, as we just saw, I have virtual machines as well, and those can also go in a cloud service. What we have here with a cloud service is we have some service name, so mcweb1.cloudapp.net. That's our cloud service, and that cloud service can be composed of platform as a service, web and worker roles, or infrastructure as a service. So the, I guess, more accurate kind of definition for a cloud service is really a management, configuration, security, networking, and service model boundary. Essentially, a cloud service is a container, right? It's a container, and we put a virtual machine in it. And whether that virtual machine is a web or worker role with cloud services, a platform as a service model, or it's a Windows or Linux virtual machine with infrastructure as a service, it still is really just a virtual machine we're stuffing in this cloud service container. Mark Rusinovich has a really great talk on this. It goes into much more detail on cloud services. He has a talk entitled Windows Azure Virtual Machines and Virtual Networks. Check that out you can go out to channel9.msdanny.com. It's on from his Tech Ed North America 2012 presentation. It's a really great talk and kind of diving into some of this stuff. So I think an important note here is when we talk about cloud services and you look at managing them in the portal, one of the things that we've noticed is that if you create a single instance VM is exactly what it looks like. It's a single instance VM created in a cloud service. It inherently creates a cloud service for you, and sometimes you don't see that inherent cloud service created in the Windows Azure Management Portal for when you create a single instance VM. If I wanted to add multiple VMs to a cloud service, that's container model, multiple virtual machines, part of that availability set, then I would see in my cloud service window that cloud service show up and show me that I have a virtual machines there, multiple virtual machines deployed to my production slot. So when it comes to which level of cloud do you want to work with, you have really kind of 3 choices that we talked about at the beginning, right? This 3-lane highway to work with. We can start off with Windows Azure websites, which give me that very fast, easy, highly portable, managed solution where I can deploy my websites, my PHP, my ASP.NET, my classic ASP, Node.js, put those websites out there. Very easy for me to move around because there's really nothing special, platform or infrastructure-wise, no APIs or anything unique there that I have to worry about, and it's all managed for me. It makes it really nice. If I want to kind of take a step on the other direction, I want to go to cloud services. Again, I get that nice management layer where operating system level patches and hardware and everything is handled for me. But it's also very versatile. It gives me a great deal of flexibility if I want to scale out or up or have different scalability options. Like I want to have 20 web servers and just 2 middle tier worker roles, kind of like web heads and some business tier logic in there. I could certainly scale out that type of architecture. Or I could look at virtual machines. Virtual machines give me that great deal of flexibility as well, right? Because we've seen they're really just there's VMs I can do whatever I want with, installing whatever software, configuring however I want to do in that way. And they're highly portable, giving me an option to move them between the cloud and on-premises as well. So a great deal of options and flexibility in the platform and how and where I want to manage my solution. So as we kind of wrap up here, just a couple of quick resources I think would be very helpful. Obviously, if you're coming from a Windows background and working with the Linux virtual machines, you want to go ahead and download and get familiar with using Putty. There's a great series of resources on windowsazure.com. Just go to manage and then Linux, really kind of showing you lots of ways to get started, lots of tutorials on how to install software, how to set up load balancing, how to attach attach data disk and a series of commands you have to run there, how to set up SSH, and gives you the syntax, the command line tools for doing things like OpenSSL and that sort of stuff there. So very easy to go ahead and get started. And of course, check out the Windows Azure Training Kit. Great resource, lots of hands-on labs on everything within the Windows Azure platform. Hands-on labs, presentations, demos, all sorts of stuff there. So be sure to check that out. Really great resource to learn about the Windows Azure platform. Just a quick reminder, now we've seen the new HTML-based portal, we've seen Windows Azure websites, we've now talked about both Windows and Linux virtual machines. Next month is Cloud Services. We'll dive much more into the platform as a service features of Windows Azure. And I'd like to thank you guys for coming out today. If you have any questions, I'll stick around here. Obviously, you can feel free to email me, follow me on Twitter, check out my blog, and I'll be happy to chat with you about anything Windows Azure related as well.
Great. Thank you, Michael, for this awesome presentation. We did have a few questions come through. To ask a question, please click on the Q&A verbiage located in the toolbar at the top left side of your screen, type your question, and click the Ask button. The first question was, you mentioned update domains earlier when talking about virtual machines. What are update domains?
Yeah, good question. Yeah, so we have update domains and fault domains with Windows Azure. The idea behind an update domain is really to ensure that when Microsoft will go ahead and update kind of the underlying platform level systems, underlying the Windows Azure operating system and kind of the hypervisor and all the stuff that runs in there. So an update domain really ensures that we don't have 2 machines going down at any time there in the kind of when there's an update going on. Really, so you talk about fault domains and up domains, they kind of work all together to make sure we don't have any sort of downtime in there. So it's spreading our machines across different update domains. So if one machine goes down for an update and a system level update, our other machines are going to be available as well.
Great, thank you. One more question was, with a virtual machine, you showed various amounts of local storage. What is the local storage?
Yeah, so local storage with the virtual machines is a really kind of neat idea. So we have our OS level disk, our operating system disks that are created for us when we provision a new image from the gallery, we upload one. We also have those data disks that we can add anything we want to in software, like if you're installing a database or something like that. I want to put those database files on those data disks. But we also have local storage. And the idea behind local storage is you're writing to the physical disk on that server. So there's virtual machines and there's physical disk backing those virtual machines. We can write to that local disk if we want. Things that would write to that typically would be like an operating system, like in a Windows environment, for example, it's the page file writes to that disk. So it gives you great performance, so that it's right there, local or easy to access. The caveat being that it's not persistent across any sort of hardware failure. Since you are writing to the physical disk, if that hard drive did fail, that's not backed by Windows Azure storage. So it's kind of a scratch space, so to speak. If I did want something to be persisted across instances, I'd want to make sure I'm using an OS disk or a data disk that's backed by Windows Azure storage. We saw how that's triple replicated and geo-replicated and all that sort of good stuff there.
Great, thank you. If there's no more questions, then I'm going to go ahead and wrap up. We will be forwarding the link to view a recording of this webcast once it becomes available. Again, thank you so much for everyone for joining us, and we look forward to seeing you on our next webcast. You are now free to disconnect. Thank you.